Taking too long. So I'm going to do this two. We'll just wait a few minutes and then we can begin.
Okay.
I can't hear you.
So I think we can begin now.
Okay.
We don't have to wait for other people. It's already 8 minutes into our time. So to do justice to you guys who came on time, I have to begin. Okay? Fair enough? All right, let's start. I'm gonna share my screen. Like before, I think I opened too many pages. Let me share my screen first, and I'll close some pages I opened. Okay, so I'm gonna close this. Let me close this one. All right. So here we are. So it's, today we'll be looking at measures of position, and this EDA actually it means as exploratory data analysis. So let's start with the measure of position, which is the main topic today. Now, under this measure, well, I'll put it this way: our interest here is to measure or to locate the relative position of any of our data value in our data set, right? I mean, of choice, one we choose to locate. So we have many of those measures that we use to locate the relative position of our data value in the data set. The first one we use, which is the easiest one to calculate, is the standard score. Or some people call it the Z-score. Our second one is we're looking at is the percentiles. Now, percentiles divide distribution set into 100 equal parts. So we can have things like decile and quartiles under the percentiles. Anyway, we'll come to that. Then we'll have the quartiles. This should be the main one we'll be looking at here. Three of them. This we are interested because these three cover. I mean, for example, the quartiles are similar. Are basically similar to percentile because the first quartile is the same as the 25th percentile. The second quartile is the same as the 50th percentile. So they are related. So that's why when we talk about things like deciles, decile is the same as the 10th percentile. Okay. Now, I know this might sound strange to you, but as we start using them, you see that they're actually easy. Now, the standard score, let me explain some of them before we do some calculations. The standard score, like I said, is used to estimate the number of standard deviations that our data value is or falls away from the mean. Now, when it is negative, we say that it falls below the mean. When it is positive, we we say it's fall above the mean. Then we can now measure how many times above the mean or below the mean it falls. And the percentile divide the data value into 100 equal parts. Now, I'll give you an example. Suppose somebody said that their credit score fell in the 70th percentile. That means that their credit score is better than 70%, is better than that of 70% of the Americans. So that's basically how we use it. If we say that your score in exam falls in the 85th percentile or 81 percentile, that means your score in the exam is better than 81% of all people that took the test. Now, the quartiles divide the distribution into 4 groups. Like I said earlier, quartile is similar to percentile because the first quartile, which is the Q1, is the same as the 25th percentile. The second quartile is the same as the 50th percentile. And the third quartile is the same as the 75th percentile. So even though quartile divide the distribution into 4 groups, we're only interested in the first quartile, second quartile, and the third quartile. So we come to this, the rest of the concept, like the mid quartile, and then the outliers, how to find the outliers, and so on and so forth. Now let us start with the first example, which is the standard score. The standard score. Standard score. Or you can call it Z-score. Or Z-score. The standard score like I explained before, is tell you how many standard deviation that the data value is away from the mean. Now, and the formula, I have it here already. This score is given by this formula. Value or data value minus mean divided by the standard deviation. There's another way we write it. I will show you in a minute. It goes this way. What's my other? I'll take you to my other workbook so we can put it in. So that our z-score becomes start formula or equation. Z-score equals z-score standard score or given by z equals x, which is data value, minus mean. I can get the mean from here. Which I find from here, divided by standard deviation, which is right here. That gives us our z-score. Okay. Now, that's right here. So this is for the population. So this is a z right here. All right. Then value is their x. Mean is your mu. Standard deviation is your delta. Okay. Now let us apply this to solving one question. It says here that the milk production for a herd of cows. I'm gonna bring it down. A herd of cows is normally distributed with a mean of 70 pounds and the standard deviation of 13 pounds. If the milk production of a randomly selected cow is 90 pounds, this is pounds. Okay, calculate the z-score. So all we have to do is to apply the formula we have, as I just gave you, which is that standard score is x minus mean over standard deviation. So The formula is right there. Now, in this case, say that the mean for this cow is 70 pounds. So the mean for our cow is 70 pounds. Mean equals 70 pounds. And standard deviation for the cow is, let me see if I have standard deviation right here, equals, let's see, 13 pounds. And the cow is selected on X. And it says, if the milk production of a randomly selected cow is 90 pounds, calculate this Z-score. So for that cow, X is 90 pounds. Okay. So the Z-score now become Z. I'm going to put it over there. Let me write it down so that I can easily compute it with my paper. Okay, got it here. Z-score, our Z is X minus mean of standard deviation, which is 90 pounds minus 70 divided by 10. So you just have to plug in this number. Say X is 90 for here, mean is for this side, and 13 is for standard deviation. So I'm going to take you to the other bookshop, other workbook, and to give you the Z-score right away. Okay, which is, I'm going to put it in. I got S is 90, mean of 70, and standard deviation of 13. Now we can get it from our Desmos. So I'm going to take it to Desmos calculator so we can use it to find the Z-score. So we got 90 minus 70 divided by standard deviation of 13, 1.54. Say 1.54. Actually, 1.5384. So we round it up to the second decimal place, which is 1.54. So I got 1.54 here equals 1.54. I'm gonna copy this and paste it in our main workbook, and then we can then interpret it. Okay. So this is right here. See? So so it's because it is positive, we say it's above the mean. It is above average. Now, so now let's interpret the interpretation of this. So this means that the milk production for this cow is the milk produced from this cow is 1.54 standard deviations above the mean. The mean milk production of the head of cow. So because it's above average, that means it should be a good stock, a good breed to be kept. I mean, if milk is the target for raising that cow, you know. Any question for me on this?
No.
Now, this is how you do the same thing. This one here, it says the average number of vacation days in certain countries have a mean of 9.4 and standard deviation of 8.6. Find the Z-score, the average number of vacation days in each of these countries. So in this case, your X is, for Canada, your X is 26. For Italy, your X is 42 days. And for USA, your X is 13 days. So you just plug them in, put your mean and standard deviation, and you get your answer. So you can practice some of the example in the course textbook and handout. It is still, this method we use here is still the process for it. So now let us proceed to the next one, which is the percentiles. Percentiles. Like I noted earlier, the percentile divides the data set into 100 equal parts. So, and I give examples. If you have percentile for a certain range, what it's going to do. So there are two formulas that we use when we want to calculate the percentile for any data set. There are two formulas we use. Now I'm going to write the formulas down. Percentile is a percent. Now, the first formula for finding the percentile. Oh, before I do that, I may say something. If this is negative, that means it is below average. Like this, if suppose our answer is 1.54, that means this cow, milk produced from this cow is 1.54 below the average milk production of the entire herd. So I want to, you to take note of that. So when it is negative, it is below average. When it's positive, it's above average. Now, so for this one, two things we calculate: the percentile rank and the actual percentile. For the percentile rank, we use this formula. Let me take you to the book. The percentile rank, okay. Rank, the formula is rank equals maybe we'll type it in. Well, this is not. This is the percentile itself. Okay. All right. Percentile is number of values. Well, remember, there is going to be a set of data which were represented by x. S1 for the first one, S2. So we can now say number of values below x okay, plus 0.5. Now, because you're moving, you're trying to move it from the continuous to district. So because of that, you have to put this correction factor. Then our n, which is the total number of values, then apply the result with 100. Okay, right here, 100. Okay, now I'm going to put it just so you have. Okay, put it back here. Okay, so this gives us the percentile rank of a data value. And the second formula is how to find the percentile itself. So that one, I will show you the formula for that. The percentile itself will be calculated using this value. Excuse me, I want to put you on the other workbook. This is what I want. Okay, keep bringing us here. Okay, I know what I'm going to do. Yeah. Okay, this is what it is. And I'm gonna put you there. Good. Now, so next one we're going to calculate is the percentile itself, Pn. Or just regular P equals n times P over 100. This one will ask you to find the value that correspond to a given percentile, so Pn. Yeah. In that case, you can use this one, where n is this total number of values in the data set, and P becomes the percentile of itself of interest. Then, of course, like you know, percentile divides data value into 100 equal parts. Yeah. So with these two formulas, we can find the percentile of the data set. Okay. So let's do it. Here it says, let me put this down first for the formula down. If you're asked to find the percentile rank, you use the first one, and this one here. If you are given the percentile and you're asked to figure out the number where the value where the percentile falls, you use the second formula. So let us apply this. It says a teacher gives a 20-point test to 10 students. The scores are given here. So here are the scores right here. Okay. This is the score right here. So one student score 18 over 20. The other one score 15 over 20, you know, and so on. You say find the percentile rank of the score of 12. Find the percentile rank of the score of 6. Yeah, find the value that corresponds to the 25th percentile, and then find the value that corresponds to the 60th percentile. So in this form. So the first thing is to arrange this data set in order from the smallest to the largest. So in ascending order of magnitudes, which I did here already. So arrange them from the smallest to the largest. Okay. So with this, we're now ready to find the percentile rank. So here, how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So our n is 10. Okay. Now, but we're looking for the percentile rank of the score of 12. So your x is 12. So x equals 12. And n, total number of values we have is 10 of them, which is your, total number of values. Then of course you need to have your 0.5 correction, which is this 0.5 is a part of the formula. Because a correction factor for, because we're moving from, continuous to district. Now, so with this, we have, with this, we can now plug it into this formula, number of values. So number of values below x. X is 12. How many values are below x? 1, 2, 3, 4, 5, 6 of them. 6 are below x. So that means that part is 6. Number of values below x. Of values below x equals 6 of them. Because if again you can count numbers that are less than 12, because s is 12. Numbers that are less than 12 here is 1, 2, 3, 4, 5, 6. So now you plug it into this formula. The percentile rank, okay, becomes put number of values below x is 6 of them. Write it down. 6 plus 0.5 divided by total number of values is 10 of them times 100. Let me put it on the screen so you can see what I'm talking about. We have that number x is the value of the interest. Number of items in the list is 10 of them. Number of values below x is 6 of them because it's 1, 2, 3, 4, 5, 6 of numbers. So let me put it in so you can see what I'm talking about. So we have percentile rank equals number of values below x, get at 6 plus 0.5, which is part of the formula, divided by total number of values of 10 of them. Okay, times 100%, times 100. So let us go to decimals and do this. Remember to put this part in parentheses. We are doing the calculation using a calculator. So I'm going to take you to decimals. So I have number of values below x. That is 6 plus 0.5. Then close the parentheses, divided by 10. Okay, then times 100. Sorry. Then times 100. 65. So which means that our percentile rank for this is 65th percentile. Yeah. So that means I'll copy it and put it on there on your our work. Remember, this is part A. So put it that way. Now I'm gonna move this down so we can have more room. Yeah. Now this is what we have. Now we're gonna interpret this. So interpretation of this. It says so now remember this is for the score of 12. Now and this if 4 in the 65th percentile. So a student who score for the test is 12 falls in the 65th percentile. See? A student whose score is 6, or the score of 6 for the score of 12 for in the whose score is 12 for in the 65th percentile. Question for me? Any question?
No.
Look at part B then. Part B says find the percentile rank of the score of 6. Okay. Now following the same process. Okay, and I'm gonna just copy this because it's the same process, but this time we're gonna change it to 6. So S is 6. This time S is 6. I will have it. How many numbers are below 6? It's the number of values below X. This is 6 right here. Only 3 numbers are below X. 1, 2, 3. So that's 3 numbers. So put 3 in here. So that means percentile rank. Okay, now becomes I'm just going to change the X to 6. But now we have 3 of them that are below 6. So we have that in mind. Let me write it down. 3 plus 0.5 over 10 times 100. So I'm taking you back to the workbook. So this 3 represents number of score below 6, 3, 10 times 100. So I'm going to take you to decimal so we can figure this out with the calculator. So I'm going to change this to 3 because it's 3 of them, so it's 35. Bringing us to our workbook, which is 35th percentile. So a student whose score is 6, 4 in the 35th percentile. So just give us this. Again, this means that a student whose score is 6, this one here, 6 is 4 in the 35th percentile. So let me just copy it from here because we have it here already. I'm just gonna change the number. So the student whose score is 6 fall in the 35th percentile. So basically that's the same process. Okay. Now this is how to find the percentile rank. Next one is to how to find the percentile. It's how to locate it in the data set. Example for the part C says find the data, find the value that corresponding to the 25th percentile. So find the value corresponding to the 25th percentile. That is part C. Okay, part C. Again, our n is still 10. P in this case percentile we are given as 25th percentile. So now we're going to use this formula, the second formula that I showed you, which is n times p over 100. And then when we get the answer, we try to use the answer to locate the percentile of interest from this list. So we have this. So having this, we can go to this place and plug it in. Okay. So the percentile value. Sometimes we can write it as p, and depending on the kind of percentile we are looking for. If you are looking for the 25th percentile, it's going to be in this form. I'll put it this way. It should be P25, which is a convention. P25. See, we get n times p, n times p over 100. So notice that here is P25. So that's what we get, and this here like just PP to be given. So that will give us equals. Our question says that it says that our n is 10. N is 10. Okay, and P is 25. And how many over 100? So I'm going to take you back. We have equals 10 times 25 times 25 over 100, which is 10 times 25. Let's do it on the calculator. Let's move. So we have 10 times 25 over 100. So 2.5. Now you have a decimal part of it. If you have a decimal part, just round to go to the next number. Okay. So I'll take it back. 2.5 is 2.5. Which point to the next number? I'm going to point the next number, which is yeah. Okay, which is okay. I can see it here. Which is 3. The third number. See? So whenever you have a decimal part, go to the next number, which is 3, third number, which is 3. This third number. See? That will give us the 25th percentile. The third number in our group will give us 25th percentile. So we have it this form. Okay. So that means it means that P25, 25th percentile equals, let me correct this before I continue writing it. Okay. Say it's the third number. You come here and we'll count. 1, 2, 3, which is 5th. It's 5. A score of 5 corresponds to the third number. Any question for me? This one?
No.
This interpreted in, as it says, interpretation. The score of 5 is the 25th percentile score. Percentile. Okay. Now, how about when we don't have a decimal part in our answer like this? What do we do? So next example will explain that. It says here to find the value that corresponds to the 60th percentile. So 60th percentile this time. In this case, I'm going to copy this from the consider this guy to change this to. Okay, no, that's this one, not this one. I'm talking about this one. N times P. It says 60th percentile. N is still 110 because it's still the same data set we're using. So that's D part. In this case, N is 10 and P is 26 because it says the score corresponds to the 60th percentile. So have it here. So now we can plug it in. Write it down. P60 equals N times P over 100, which is 60 times 10 over 100. Let me write it down on the screen so you can see it. So this gives us we have it P60 60 percentile. So 10 times 60 over 100. So let's put it in decimals. 60 times 10. So 10 times 60. So I'm going to change this to 60. Which is 6. If you look at this answer, there's no decimal part. So what you're going to do is to use the 6th number and the 7th number divided by 2. It's going to be the 6th number. If you look at our list, after they arrange it, this see 1, 2, 3, 4, 5, 6th number and 7th number divided by 2. If it is 5, then you're going to do the 5th number and the 6th number. Now, if the answer is 2, you're going to do the 2nd number and the 3rd number divided by 2. So in this case, our answer is okay. Let's solve it first. We'll solve it and I'll get this answer. Let me share this. Our answer is becomes we get from the decimals calculation. Our answer is 6. So you have it in this form because of that. It is 6, which means the 6th number, okay, the 6th number plus 7th number divided by 2. And from our question, we can figure out this 5th and 6th and 7th number. Look at our list here where we arranged it. So 1, 2, 3, 4, 5, 6th and 7th. That means 10 plus 12. Let me write it down. 10 plus 12 over 2. So that gives us so this is the 6th number, this is the 7th number. I'm gonna put it there. 10 plus 12. We are doing this way because there's no can be done yet in another way. 6 plus some number is, I wrote it down, 6 plus, well, I didn't write it down. Okay, let me write it down, take it down, write it down. 6 plus 12. Let's see. 1, 2, 3, 4, 5, 10 plus 12, sorry, 10 plus 12, 10 plus 12. 10 plus 12, divided by 2. Yeah. 10 plus 12 is 22. I can answer that one off head. So 22 divided by 2 is 11. Am I right? No, am I right? 10 plus 2 divided by 2. I got 12. Sorry, I got 11 right here. So the score of 11 corresponds to the interpretation of this. So that means that P25, P6 is equals to 11. So this means that the score of 11 belongs to the 25th percentile. Questions?
No questions.
Good. So let us round up. I want to show you how you can do this in Excel. So let me put the numbers in Excel. What is my Excel? I'm going to open it. Okay. Teaching. Okay. All right. It's coming up. Okay. Now it's opening now. Suppose we have this. The measures of position. Usually, let's say the hard part is the data entry part. So in this case, we have these numbers, and I've already arranged them.
We can't see the Excel file.
So you can, okay, let me open it there. Okay. All right, can you see it now? Can you?
Yeah.
Okay, now. So we have these numbers that I have entered, measures of position. We have the same number we're using. Let me use the same number we're using. We have 2. With a set, it doesn't really matter whether they are arranged in order or not. So I'm going to just put them in. If I have them 18, 15, 15, I got 12 and 6, 6, 8, 2, got 3, 5, got 20 and 10, 20 and 10. So now we want to calculate the percentiles. So I'll call this one the first one we did, let me see, was calculating the percentile. It has to find the 25th percentile, and then the number corresponds to the 60th percentile. So let us look at it. 25th percentile, doing this. So that's 25th percentile. 25th percentile. Okay, make it okay equal 5 percentile. You can see that it will come out percentile EXC. Okay. Now, 25th percentile is the same as the first quartile. Okay, but you know that percentile is in decimal form. So let's see, 20 percentile. So you have to highlight this, comma, then put the percentile of interest. 25 should be 0.25, I believe. Then enter key. 4.5. Maybe I entered the wrong thing. Let me. What answer do we have for the other one we have in the paper in our workbook? We have an answer as 25th percentile, the third number, which is 5. To give us 5, give us 4.5. Let me see why. 4.5. Did I make any mistake when I was typing the numbers in? Okay, 2, 4, 6, 8, 10. And the 10 of them, okay, equals percentile. Okay. Array. Comma 25. Let's because it is in percent, so you're gonna be 0.25. Let's see what 5. Well, it's giving us the kind of average. I mean, sorry, estimate. What answer we have in paper is 5. So we can adjust this. Okay, let's see. Okay, percentile. Okay, this is EXC. So it return the kth percentile values in a range where k is the range 0, 1, all the way to, okay. Maybe you give it in 10 multiples of 10s. Let us try 50, 60th percentile and see if it is what it's doing here. Okay, let me one more time, percentile. Okay, this is right here. And then let us try 60th percentile, comma, 6, 0.6 for the 60th, 11.2. So if you look at what we have for the 60th percentile, you can see that it gives us some, let me see, say 11. So as a matter of fact, let me put it this way. The reason why we have this kind of difference is because of we did the correction factor. I think that should be the only reason. To get for the 50th percentile, 20th percentile is 5, but it gives us 5.25. So let me repeat 20%. Let me put 60th percentile. Okay, percentile. Yeah, now we'll get 20th percentile from this one equal 20th percentile. Okay, I highlight this. Okay, percentile. Okay, tile. Okay, array, comma, 0.25. Okay, 5.25. Then do the same thing here, percentile. a dot esc array, comma 0.9, 0.6 for 60th, 0.6. Okay. Now, there must be a reason why it's giving us these different answers. The last time, let's try the last time, and then we can end the class for now. Okay, percentile is out here. Let me look at this one. Return percentile where k is the range. Okay, 0.1. Let's try this one, see if this one will be better. Okay. You highlight this. Come on. 0.25 is given to 5.25. Okay. Equals percentile. This one here. And highlight this. Comma 0.6. Which this is approximately 11. This is approximately 5. Let's put it that way. So this will give us the percentile. The difference is not that significant, but at least it gives you a correct estimate. So it depends on the kind of the command we used. Like if you use the other command, like this one here, exc, then highlight this, comma 0.25. It gives us 4.5. See, which is approximately 5. And if you use this one percentile and highlight this, comma 0.6, give us 11.2, which is approximately 11. So you have it in the back of your mind that percentile is you have to be a number in digits, countable digits. So you just round it up to the next number. Okay. Any question before we leave? Any question? Hello?
No questions.
All right. I'll see you guys next week. Have a nice weekend.
All right, you do the same.
Professor, is the test gonna be on piercing?
Yes.
Okay, so I had made my account and everything, but when I went to put the access code in, it said like the access code was invalid.
Sorry, right?
Yeah.
You're still having the problem?
I'm sorry?
You're still having the same problem?
Yeah, like I put the access code in for our class that you put on Canvas, and it was just saying that it was invalid. Is there like a different one that you posted?
Some students were having that issue too. Call that, there's a number I showed you. Call that number, see what they can help you with so that they can put you in. Okay?
Okay, to see if they can put us in, put me in our class.
Yeah, in the class. You have that information. I also put my class ID there so you can see it. They can use it. Use it. They ask you for it. Okay?
Okay, I'll call them.
All right. Have a nice weekend.
Thank you. Bye.